We're now going to start working with angles on the coordinate plane. And as we kind of get into this, I want to just first look at the coordinate plane, which I have over here on the right, and think about how angles are placed there. So what we would do is we would actually have an angle where the vertex is here at the origin. And what we would call the initial side, and I probably can't draw this straight, in fact, I'm not even going to try to, is going to lie on the positive side of the x-axis. So I would have an initial side somewhere on the positive, not somewhere, but on the positive side of the x-axis. And then I would have a terminal side somewhere else there here on the coordinate plane. Now let's think about this rotation, if you will, for a moment. If I were to begin here at the x-axis, and if I'm drawing a positive axis, I'm going to move in a counterclockwise direction. And we can also have negative angles, which means I'm going to go from the x-axis in a clockwise motion, and that gives me a negative angle. Now I need to think about where we are here on this coordinate plane. So if I'm lying right here on the x-axis, this would be, like, say, at 0 or 360 if I've made one trip around, or 2 pi. That would be in a clockwise direction. That'd be I'm moving counterclockwise, not clockwise. And if it's a negative angle, well, at this point it would be 0 or negative 360 or negative 2 pi. Now up at the top of the y-axis, at this point we're talking about either 90 degrees or pi over 2 if we're talking radians. And then on the negative side of the x-axis, at this point we would be at 180 degrees or pi if we're looking at radians. And down on the negative side of the y-axis, well, this would be 270 degrees or 3 pi over 2. Now all of those are measures of a positive angle. And if it's negative, then all these things kind of flip around, if you will. In other words, down here at the negative side of the y-axis, well, this would be negative 90, and this would be negative pi over 2. And back up to the negative side of the x-axis, well, this would be negative 180 or negative pi. And up at the positive side of the y-axis, this would be negative 270 degrees or negative 3 pi over 2 if we were going in a clockwise direction. Now, I'm going to graph some of these in a program called Geogebra, which I would really recommend. It's a free app. You can get it on your computer. I think you can even get it on your phone. I've never tried to use it on a phone because I look at a phone as a check-in device. I don't consider it a working device. Students, however, seem to think, with my experience, they tend to stick with phone for just about everything. And it is a free app on the phone. I'm just not, again, I don't have any experience personally in working with it in that way. But not only are we asked to draw angles on the coordinate plane, we're also to find coterminal angles. Now, a coterminal angle is any angle that is going to share both the initial side and the terminal side. And we can actually find those algebraically as well. In fact, we may take a little bit of time here, right here, and work on that part. So let's say that I have drawn an angle, and if it's negative 30 degrees, I'm going to change colors on this thing, then that terminal side is going to lie somewhere down here in the fourth quadrant. We have moved negative 30 degrees in a clockwise fashion from the x-axis. Now, if I had an angle that was sharing this coterminal angle and it was positive, it would be moving around this direction back to this terminal side. And so algebraically, I could find that by saying, okay, well, I got negative 30 plus 360. What would that equal? Well, that would equal 330 degrees. So a 30-degree angle and a negative 330 degree angle is a positive angle sharing the same terminal side. Now, what about a negative angle? Well, I would go this initial 30 degrees and I would move clockwise around back to the terminal angle. And algebraically, I could say, well, okay, I had a negative 30, and from there, I went another negative 360, and so a negative angle that would share that same coterminal side would be 390 degrees. Now, we can do the same thing in radians. So here we've got a positive 3 pi over 4 radian measure. And actually, see, here's pi over 2. Well, 3 pi over 4. Well, pi over 2 converted into a common denominator of 4 would give me 2 pi over 4. And so that terminal side, I'm going to change colors again, would be somewhere out here. Now, if I think about what would be a positive angle that might share that same terminal side, well, I could say, well, I could take 3 pi over 4 plus, I'm going to go a complete revolution around, 2 pi. And if I were then to get that where I could add, I need a common denominator, so that's going to equal 3 pi over 4 plus 8 pi over 4, right? 8 pi over 4 is 2 pi. And so therefore it's 11 pi over 4. Now again, if I want to have an angle that is going to be a negative going clockwise, I could say, well, okay, let's see, what could we have here? I could have 3 pi over 4 minus 2 pi. That should get me there. And again, 3 pi over 4, and we'll get a common denominator of 8 pi over 4 minus 8 pi over 4. And algebraically, I could say that that's at negative 5 pi over 4. All right, we'll talk about that more. Now, I want to go over to Geogebra. I want to graph it there. I want just to show you how to use the program. We're going to graph both a negative 30 degree and we're going to graph a 3 pi over 4. And then maybe we'll talk about how we could use that to find a coterminal angle. Well, I'm here on Geogebra and I'm going to draw an angle. We're going to draw that negative 30 degree angle. The first thing I'm going to do is I'm going to go, I want to see a line segment. And I'm going to put the vertex here at the origin, and I'm just going to extend it out. I don't know. That looks good enough. All right, so I have laid down an initial side on the x-axis. And now I want to go in here and say, okay, well, I want to see a negative 30 degree angle. Now, if it's negative 30 degrees, remember, I should be in the 4th quadrant. So I'm going to hit this angle tool, and I'm going to say angle with the given side. And it asks me to find the leg, so I'm going to go here and then to the vertex. And then it pops up and says, okay, well, tell us your angle. And if you notice right here, it says counterclockwise and clockwise. Well, counterclockwise is positive, clockwise is negative. So I'm going to say I want to see a negative 30 degree angle, which means I want to see 30 degrees clockwise. And I'm going to click OK. And it puts a point down here. And I'm going to go back to my segment tool, and I'm just going to join these 2 points right here. And so Shazam, I've got a negative 30 degree angle lying in the 4th quadrant. Now, I guess just for fun, what if we wanted to see a coterminal angle that was positive? Well, I know I'm going now counterclockwise. Well, how about this? I'm going to say, let me see an angle. I want to see a given size. I'm going to click my leg. And I want to say, okay, I want to see one that is 330 degrees counterclockwise. Well, there you go. See, I've got one, and now it's 330 degrees, and I can see that it's sharing the same initial side, and it's sharing that terminal side. So it is a coterminal angle. Now, what if we go the other way? We're going to go negative. And again, I'm going to go angle with a given size. I got to hit my leg and my vertex. Let's see what happens now. Let's say now I want to go 390 degrees in a clockwise motion. And Shazam, it appears right there again. It's going to be at the same point, 390 degrees. So a negative 30 degree angle, a positive 330 degree angle, and a negative 390 degree angle all are going to share the same terminal side. I'm back over here on Geogebra again. This time we were looking to graph 3 pi over 4. So again, I'm going to take my segment tool. I'm going to put the vertex at the origin. I'm going to take a leg. I did a line. Well, so that'll work. I put a point there at point B. And now I'm going to go to an angle of a given size. I'm going to click my leg, which goes from B to A. And it pops up and says, okay, what do you want? Well, we want to see an angle 3 pi. Notice it gives me a little calculator, a little keypad down here. 3 pi over divided by 4, and I'm going to eliminate that degrees. And I say I want to go counterclockwise because this is positive. So I hit OK, and it puts a point out there, and I'm just going to join that point to the vertex. I need to hit my segment tool. Should have hit my segment tool. And I'm going to hit A to B. And that is, I don't know why I chose a line again. I'm actually going to delete that. I'm going to hit the segment tool and go from the vertex here at point A to B here. And that's actually 5 pi over 4. Now you happen to notice that that actually equates to 135 degrees. Here's a tip. On the coordinate plane, if you see any radian measure over 4, something divided by 4, it's going to equate to some type of 45 degree angle. If it's in the first quadrant, it'd be 45. If it's in the second quadrant like this one is, it'd be 135. If it was in the third quadrant, let's see, 180 plus 45 would be 225. And if it was in the fourth quadrant, 275 plus 45, 315. Now, just for fun though, we're going to go ahead and draw our negative coterminal angle. So I'm going to hit my leg again. And we said our negative coterminal angle would be negative 5 pi over 4. So I'm going to hit my angle with the given size. And we got to hit my points now. Point. And this time I want negative 5 pi over 4. Let's see if that's, and I want to go, no, excuse me, I don't want to do that. I want to go 5 pi over 4 in a clockwise direction. That makes it a negative angle. Let's see if it shares the same terminal side. We're going to go clockwise. Okay. And it pops it around. and actually says that it is what? Negative, can't read it. Anyway, I can see that it's going to share that same coterminal side. Okay, that didn't really work out exactly like I was hoping for. But hey, hopefully we'll get the drill. We'll figure it out in class.